Example number 3. Using the definition of the derivative, find f prime of x, then find f prime of negative 5, f prime of 0, and f prime of 6 where the derivative exists. And our function, f of x, is 50 over x. So the first part is to evaluate the difference quotient. F of x plus h minus f of x over h. Well, f of x plus h will be pretty easy this time because we just have that 1x and we have to replace it with x plus h. So our numerator of this difference quotient is 50 over x plus h minus the original 50 over x, and all of this is over h. So I need to reduce this expression because I can't find the limit with that h in the denominator, because I would end up trying to find a zero denominator, and that's not possible. So instead, what I want to do is I want to find the least common denominator. I could get a common denominator and add, but instead I'm going to multiply by the least common denominator. And so it's x plus h times x. So using these two denominators as my least common denominator, I have to multiply every term, top and bottom, that's the key, times x plus h times x. Simplifying a little bit, the x plus h divides into x plus h and leaves a 1. The x divides into that last x and leaves a 1. And so left in the numerator is a 50 and an x. So 50x minus a 50 and an x plus h. And in the denominator, I'm going to rearrange a little bit so you can see I've got an x times an h and an x plus h, and you'll see when I multiply what I get there. So my numerator gives me a 50x minus a 50x minus a 50h divided by x squared h plus x h squared. Now in my numerator, the 50x's are going to reduce out to 0 because those add to 0. I'll be left with a minus 50h over, and I notice that there are some common factors in this denominator. They both have an x and they both have an h, so I'm going to factor out the x and the h, and that's going to leave me an x plus an h. Now I'm going to reduce this factor of h. Look, it's a factor there and there. Those reduce to 1. And I end up with a negative 50 over x times x plus h. And you can multiply that out, negative 50 over x squared plus xh. So that's the difference quotient, the first part of the problem that they're asking me for. So it's negative 50 over x squared plus xh. Now when we do the limit, as h goes to 0 of negative 50 over x squared plus xh, that's the limit. H goes to 0, negative 50 over x squared plus x times 0. Well, that's a 0. And so my final derivative ends up being negative 50 over x squared. So to evaluate the derivative at negative 5, negative 50 over, in parentheses, negative 5 squared. Whenever you substitute a variable expression or a negative, always include it in parentheses. That's going to be negative 50 divided by 25, so that's a negative 2. Then f prime of 0, well, look at f prime of 0. That would be a negative 50 over 0. Uh-oh, that's undefined or does not exist. Okay, so we say the derivative doesn't exist because you're not allowed to divide by 0. But we can do f prime of 6. That's negative 50 over 6 squared. Negative 50 over 36 reduces to negative 25/18. So negative 25 over 18.